Testing, testing, testing. Man, the latency on this is something else. Be right back, folks. Yeah, well, I tried playing with the quote-unquote low latency settings, yesterday when I was setting things up, and it just seemed to break everything instantly, so, probably just better to not worry about it too much. So we will get started at precisely 12:30, because that is when class starts. But in the meantime, how are things? How is everybody today? Is everybody staying sane? My goodness. Is that what happens to us when we die now? We just become systems of information on the internet that can still, chat to people and stuff? Oh, thank you. This is, just the one corner of it, but, you know, it is what it is. Yeah, I figured something was, something St. Patrick's Day appropriate. Yeah? Yes, a very old pair, yeah. But, you know, I am gamer. I game. I do much game. Ha! Bowser! That's who. Yes, I agree. Let's get started! So, first of all, happy St. Patrick's Day to you all. Top of the morning. Even though it's, the afternoon. I don't know, I've never been quite sure of whether 12:30 counts as afternoon, because it's still the noon hour. But anyway, so let's start with a sort of housekeeping issue. It's recently been brought to my attention that the VPN thing is not going to be a sustainable solution for assignment submission going forward into the future. Got an email that has been making the rounds from UTS on the subject of the VPN. Turns out that the school only has 750 simultaneous VPN users that can be logged on using VPN at the same time. And given that there are quite a few people in the school, this is obviously not going to work very well for us, because there's about 300 of us just alone. So, just this class, if it was all logged on simultaneously, would blow out almost half of the entire university's VPN licenses. So that's obviously that's not going to be a sustainable solution going forward into the future. So what we're going to do as an alternative to that, I'm still in the process of sort of drawing up the plans for it, as this was a thing that dropped just this morning. We're going to be doing essentially distribution of the Jupyter notebooks through Avenue, which you do not require the VPN to access or submit things to. And then basically what's going to happen, in theory, again, this might change, what's going to happen is we're going to accept the submissions through either Avenue or Jupyter Hub if you're lucky enough to be able to get on. Although, given that VPN resources are restricted, probably a good idea to just avoid the VPN at this point. Allow access to people who need it for more important things that you can only do through VPN. Anyway, we're going to have the Jupyter notebooks available through Avenue and submitted through Avenue, but you can also submit through Jupyter. Basically, Eric has got a script where he can automatically put up all of the hidden test cases into submitted assignment files post fact. So it looks like that's what we're going to be how we're going to be handling it. So we're still going to be doing the auto grading through Jupyter Hub. We're just going to allow an alternative method for assignment submission, if that makes sense. But yeah, so just looking at chat. By the way, I'm looking at chat on my phone down in like this corner, so How is your Corona bunker? Well, it's holding so far. Although I can see the viruses pressing their ugly faces against my windows, just like in Dr. Mario. But so far we're doing all right. Anyway, yeah. So once again, I'll be publishing a sort of policy document outlining the new procedure for assignment submission. But that's essentially going to be the long and the short of it, with maybe a few modifications. Yeah. So, again, stay tuned. But yeah, anyway, let's get back right into. Yeah. Okay. I have a question. Is A8 still due this Sunday then? Yes, all of the assignment due dates are not going to be modified. This will be sort of the goal overall with all of this stuff that's been going on is to introduce minimal interruption into the schedule as it existed beforehand. So the assignments will still be due regularly on Sunday. The tests will occur. Oh, that's the other thing I should mention. Test 3 is going to occur on the day that we were going to have test 3, but it's going to be a whole day take-home test. The test is going to be released at 9 a.m. on that day, which is... oh my goodness, I need to check the document, actually. It's going to be... I think it's the 31st. Anyway, some of you may have seen that I released the sort of official delivery plan, which is based on a template that was submitted, sort of passed around by the department. Most of that document is going to be very boring for you to read, but the important bit is I have hammered out what's actually happening with respect to the tests to the test and the final. Yes, March 31st. So 9 a.m. March 31st, we're going to have the test released, and then submission of the test must occur by 9 a.m. April 1st. That is, there will be no late submissions accepted, and given that we are moving away from the VPN, I am not going to be hearing any complaints about how you weren't able to get through the VPN and submit it on time. Ha 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 ha. Anyway, so pursuant to that information, the final was originally scheduled for April 13th, and we're going to have basically the exact same thing go on with the final. It'll be made available 9 a.m. April 13th, and the submissions will close 9 a.m. April 14th. After that point, no late submissions will be accepted. Some professors, I think, have been sort of dealing with the fact that exams are no longer existing by just sort of removing them and adjusting the sort of assessment weightings in the syllabus in accordance. I am not going to do that. I believe, I feel that because we sort of anticipated things beforehand, we are able to deal with the situation and with minimal sort of modification to the course as it stood, which again, my goal through all of this has been minimal modification of the course, so that you can still feel like your credit is worth something. Anyway, so Larry156 asks, how do the notebooks work without JupyterHub? Included in this whole package of information that I'm going to distribute will be instructions on how to use the Anaconda Python distribution to install a local instance of Jupyter. You may execute and run your Jupyter notebooks in hopefully precisely the same manner as you would connected to the server, but you would be running it off of... Oh, sorry. The voice is echoing. Pardon me for a moment. Let me just check the audio. Oh, pity's sake. Okay. So is it fixed now? The audio good? Fine now? Okay. I'm going to proceed on the assumption that the audio has been fixed. I don't know what was causing that, but hopefully it doesn't happen again. Anyway, what was I talking about? Yes, so Anaconda. Anaconda is a sort of well-supported Python distribution that is cross-platform, so no matter what system you're running, you should be having very few issues getting Python or getting Anaconda installed and up and running. And you will, again, I'll publish specific instructions on how to do this, but hopefully there will be sort of minimal difference between the manner in which a Jupyter notebook works on Anaconda and on the server. So we're doing the tests in take-home format. This is in response to Nishant's question, how's it going to work? Will we get the whole day to solve the paper, or will it be open for an hour? You will get the whole day to solve the test. You'll be given a whole day to come up with your solutions to the questions in the test. again from 9 a.m. the day of the test to 9 a.m. the following day. Yep, that does mean the questions are a little bit more meaty. The tests are no longer designed to take you 50 minutes. They're designed to take a little longer. But yeah, that'll be the format for the test. Once again, all of this is going to be, I'll have more specific information related to Anaconda and its use for the Jupyter notebooks later today. So, yeah. So the whole point of using this is to get away from the VPN. For those of you who just joined the stream, the VPN has a pretty hard cap on the number of people who can access it simultaneously. So we're going to be moving away from it, and we're going to do things through Avenue instead because it does not require the VPN. It can be slow sometimes, but I've never had a failure to log in. And even now, we're having a lot of people in the class emailing me about, failure to log into VPN. What do I do? What do I do? At the moment, the answer to that is, well, you can try again in a few minutes. Usually that's, usually you'll get through if you keep trying for a few minutes. But we want to move away from it completely. So, yeah, anyway. So that's all that. I guess we can move on to today's lecture material. Okay, so to answer Brandon Ho's problem, or question, sorry, I'm a bit confused. So for the upcoming assignments, you will accept both Jupyter Hub via VPN and via Avenue, but for the midterm 3, it's only through Avenue. No, for midterm 3, it will also be both through Avenue and through the VPN. Yeah. Okay. Yes. Let's go. So, when last we spoke, we were talking about classes. Classes, of course, are a method of abstraction which allow you to bundle together variables and functions, essentially, and name them slightly different things. Variables essentially get renamed into fields. I call them fields. There's a couple of different things that you can call them. It depends on the language. Attributes are a way that probably Python prefers to call its variables that exist inside of a class. And of course, the functions that exist inside of a class are methods. So, we had talked about a number of things, overloading classes, initializing classes, all kinds of interesting things, defining custom comparator operations. But we'd kind of gotten into this idea of inheritance. So the best way to, I think about the concept of inheritance as it applies to classes is to think of it as a set-subset relationship. So when you have a set, and a set that's a strict subset of that set, everything inside of the subset is also inside of the larger set. This is roughly the situation you're talking about when you're talking about an inherited class. So on this slide, slide 27, we have a couple of pieces of nomenclature which are important. We have a derived class, and we have a base class. The base class is the class that's being inherited from, and the derived class is the class that is doing the inheriting. So in this particular instance, we're talking about the colored point class, which is inheriting from point. If you remember our definition of point, which was right here on slide 21. We had an initializer and a few sort of relatively trivial operations as applied to points. So colored point, all we're doing is we are introducing a new parameter, a new attribute or a new field called color. And upon initialization, we require not only x0 and y0, but the color parameter as well. And of course, we have this new darken method, which just takes the whatever the name of the color is and adds dark to the front of it. With respect to that, when you are inheriting a class, it may be necessary for you to override existing definitions in the class you're inheriting from. So the most obvious example of this is the initialization method. Pardon me. So with the initialization method, obviously if you've got new attributes that you need to provide definitions for, you're going to have a new way of doing that within a new initialization method. However, it's still very, very possible to make use of the initialization method that was written for the inherited class. So I would like to draw your attention to, I can't actually highlight on this. In the initialization method defined for colored point here, we have the line point dot init self x0 y0. This is an invocation of the initialization method contained within the point class. I have a question. Why didn't the method color have the argument color in it? We don't have a method color, we have a method darken. Oh, yeah, you said that in your next question. Sorry. It doesn't need it. When you're calling the method darken, and this is actually an important point, so I'm glad that you brought it up. Although I see chat is also answering the question for you. It is a variable bound to the object, so when you passed in self, you passed all the data bound to self. Yes, that's a good description of it. So so you're passing in self. Self is a reference to an instantiated object of the class that is being defined, right? So self is a colored point. Since color is an attribute of colored point, self will contain a color field or a color attribute. You can reference that color attribute of self using dot syntax. Oh my god, I wish that my brother would stop texting me. I can't shut off text messages. Sorry. Good lord. You don't need color. So generally speaking, the purpose of a method is not necessarily to define some operation strictly related to inputs and outputs. That's normally what a function is for. So if your output can be defined, strictly in terms of the inputs with reference to no sort of other extraneous values, then it's properly a function. But if you have a function that specifically operates over the attributes of a class, then it's properly considered a method. Another way of thinking of a class is to sort of bind the scope of what would be considered global variables all over all of the methods in the class, right? So if you think about the scope of color, it's bound to the instantiated colored point object, whatever that should be. It doesn't exist outside of that scope. So you can kind of think of it as it's kind of local to the class, but global to all of the methods defined in the class. I don't see which aspect of the base class point is inherited. Yeah, you don't. It's implicit. So if we go to our next example, you see how point.init self xo, this sort of makes it, this defines self as having the x and y fields as was defined previously in the point class, right? So all of that is inherited implicitly. It's not explicitly, you don't have to explicitly state it. That's the point of setting up an inheritance relationship. So colored point is also going to have access to all of the methods that exist inside of the point definition as well. So things like our distance method or our scale or move methods are also applicable to colored points as well as points. Yes, point is another class. It's defined on slide 21. Yes. If a new argument is introduced in the method darken, will that argument be global to all the methods in the class? No, it'll be local to the scope of the darken method. Because with respect to that, like in the same way that when we have parameters to functions, we consider the parameter to be local to the scope of the function. In the same way, when we have a parameter to a method, that parameter is considered local to the scope of the method. So why do we need to? So if you guys have a question for me, if you could just tag me in the questions, so I can just sort of at a glance see which ones are directed to me. Why do we need to make point.self method even if we are inheriting from it? I'm not sure I quite understand your question. Point.self. Oh, point.init? I mean, okay, so there are like two approaches to it, right? In slide 27, you see a version of the initialization function which does not use the initialization method of the point class, right? Self.x and self.y are just referenced and assigned explicitly. There's nothing else going on there. However, this is if you're dealing with large classes with large numbers of attributes or fields, this can get cumbersome. You would have a lot of repeated code. And as you are probably aware about programming, we like to avoid repeated code whenever we can. So this is demonstrating how you can use point.init, the initialization method from point, within the initialization function method, of a class that inherits from point. Yes. Yeah. So the place, and this, this varies by programming language. I know that in C#, you define locally or globally, you define the attributes of the class sort of outside of a method at the top of the class, typically, rather than inside of an initialization function. This is kind of a Python thing. If you have to alter an existing thing in a parent class, you have to redefine it. Yes. Yeah. precisely. It's important to note that you can do this not just with the initialization function. You can also do it with point.eq or point.str. You don't have to do it with magic methods either. These things that sort of overload things that are provided by the object class. You can use any method that you defined in an inherited class. You can use that by referencing the inherited class name. This can be extremely useful. You can see, for example, in EQ, our definition for point.eq, which is right here on page or slide 26. Sorry. This is simply equality comparison between self.x and other.x, and self.y and other.y, just with Boolean conjunction. And to that, we add self.color equals other.color, and we have the Boolean conjunction of that as well. So essentially, we are extending the definition to say if all of the attributes are the same, then it is the same point, including the new one of color. Yeah. So, are there any questions about that? Not sure how long the latency is at this point. I suppose I can tell how long the latency is by checking how long it takes to move slides. Yeah, okay. So, classification then. So this business of defining classes and classes inheriting other classes. Good Lord, 53 seconds, Jesus Christ. Anyway, this classification scheme, it has sort of, it's a very good analogy. It's a very good abstraction mechanism. It is, in fact, one of the abstraction mechanisms that the human mind uses to classify objects or classify things. You can think of like all nouns as being, in some sense, grouped into this overarching system of inheritance that classifies all things that exist inside of human knowledge. A very classical analogy for all of this is the system of the classification of biological organisms. So you can sort of imagine the hierarchy of the animal kingdom, right? If you have a human being, right? Human beings are primates. Primates are mammals. Mammals are animals in the kingdom of animal, and then animals are living things, right? A human is all of those things, right? But in the programmatic sense, you can think of human as inheriting primate, which inherits mammal, which inherits animal, which inherits, in this case, in the case of the diagram on slide 29, material object. Humans, of course, have subcategorizations. Shopkeeper, artist, and dentist all inherit human, etc., etc. So this system of classification is an extremely powerful abstraction method, and I want to draw a distinction, though, between inheritance and having a parameter that is, or having an attribute in a class that is a another defined class. Those are two different things, right? So in one case, it's one of these types of sort of set-subset relations. However, with the tutorial that's going on this week, you'll notice that we are using subclass or sort of sub-object notation in order to construct binary search trees. It's incorrect to say that binary search tree inherits itself. It does not inherit itself. What it does is it defines instances of its own class within itself, so it's a recursive class. Of course, the definition does not necessarily need to be recursive in order to use this type of subclass notation. You can have sub-objects of a different type of class, and we'll get to examples of this later on in this set of slides. But there's a difference between inheritance and containing attributes that are of a subclass. Of a particular class. I call them subclasses. It's sort of, they organize themselves into a hierarchy as well. But anyway, so yeah, inheritance was first used in a computing context in Simula 67 for simulation programs. Back in those days, these were sort of in the heady days of science fiction's influence on computer science, where they thought that teaching a computer to, for example, recognize an object or a definition of something, like what is a human being, they thought that this would be extremely easy, and it ended up not being. In fact, one might argue, like, it's, I think, still somewhat open for debate whether all of this machine learning, quote-unquote, type stuff actually qualifies as computers being able to learn and understand, something like definitions of words. Of course, in order to say that, you would have to know how a human being understands definitions of words, which is non-trivial either. But anyway, this was originally influenced by stuff like the work of Isaac Asimov with his laws of robotics, which he thought would be very easy to implement. But it turns out, with respect to Asimov's laws of robotics, it's actually pretty hard to tell a computer what a human is, which is sort of the first stumbling block. Anyway, the system of classification, though, that developed into object-oriented programming sees its roots in that era. And if you've ever looked at like these lists on the internet of what the most popular programming languages are and which programming languages you should learn if you want a job, that type of thing, you'll notice that that list is dominated overwhelmingly by object-oriented programming languages, and there is a reason for that. So, moving on to a specific example, the colored point example that we were discussing before, our system of classification is object, point, then colored point, object being the most general thing, and point being the next most general thing, and colored point being the most specific thing that we have defined. So we start running into an issue if we were relying on type to tell us things. So with respect to the type function, you might remember the type function. We used it in the first few lectures to determine, what the types of, integer, floating point, or Boolean literals were and stuff like that. When you call type on a instantiated object, it will return back to you that class, the class to which the instantiated object belongs. Note, it does not return the class's name. Notice in this assertion that we have type p is equal to point. point is not in quotation marks. So point is not a string. That is a reference to the actual class, not just the name of the class as a string. So, so this assertion would follow through. It would pass. With respect to Q, which is instantiated as a colored point, if we call type over Q, we of course get colored point. However, if we call type over Q and try to equate it to point, this will not work. So point and colored point are considered to be distinct entities with respect to equality comparison, essentially is the point here. Despite the fact that colored point inherits from point, a colored point is not a point with respect to equality. So, this is fine. We have a different mechanism for determining inheritance. In this instance, tells you whether X is an instance of a particular class respecting inheritance. So, and I apologize for the cutoff there. So assert is instance P point. That will tell that again. That will pass. It's similar to the equality comparison because you do need to. This is a binary function essentially. You need a reference to the instantiated object, and you need to know what class you think that it might be an instance of. However, you can see that with Q is an instance of both colored point and point. So again, is instance it reflects the inheritance structure of the classes, whereas type does not. Is that cool? I haven't heard from chat in like 10 minutes. Are you guys still alive out there? Cool. I'm just waiting to see if anybody has any questions. Okay. Oh, that's a shame. Succumbed to the zombie hordes, I see. So, good. Well, with respect to, in some ways, dead people make better employees because, if you're a ghost, then you don't need sleep or you don't need cigarette breaks or anything like that. So, is it possible to derive a class from two different classes? Well, yes, actually, that's what this current slide is all about. Let me get into it. So we have this concept called multiple inheritance. Up to this point, all of the examples that we've been talking about so far have been examples of a class inheriting one other. I hope I have the higher kill count. Oof. No, I can't let Curtis beat me. Has to be me. Anyway. So with respect to multiple inheritance, you can inherit from more than one thing. In this particular instance, we have redefined our colored point class in such a manner to abstract all of the details of the sort of color property. We've taken that and put it in its own class. This would be a fantastic idea if the color attribute and all of the methods associated with it are something that you want to have applicable to more things than just colored point. Imagine if Curtis was watching the stream. Ha ha ha. Yeah. The labs are fine, but those projects give me a migraine. Yes. Yeah. Well, whatever. I'm sure he's not watching the stream. I'm sure he's got better things to do. Anyway, so in this particular instance, point is defined as we have defined it so far, but you can see that color has its own initialization method. It has its own equality and string methods, and we have, of course, the darken method, which applies specifically to color. And then that has the interesting effect of making our colored point class mostly just a matter of hooking up parameters from sort of these global calls to the more local or to the corresponding method calls of the inherited classes. Well, I mean, you don't necessarily need to know. Question: is it correct to assume that a person going into a computer science program should already know Linux? And personally, I would say no. That's the purpose of having the computer science program. But anyway, are the clovers hypnotic? Good. You will do your assignments. So, not to beat it over the head too awful much, but you can have things inherit from more than one thing, and it's a great way to increase the modularization of your program. You could imagine, like, we might have, a point class and like a polygon class and a, surface class if we were to, increase this to, a larger variety of geometric shapes. Like we might also include, this type of organization would give us the ability to, for example, extend point to three-dimensional space relatively easily. Although the change would if you want that third component to be modified by when you create colored point or anything that inherits from point, you're going to have to propagate that change through all of the classes that are using point.init. Okay. Honestly, I didn't know that the background was hypnotic before I selected it. So, just a quick note on this stream and the point at which it's ending. I'm unfortunately going to have to end this stream pretty promptly at 1:20 because I got to get the next stream up and operational. If you guys have any leftover questions, I guess you can jump into the stream for the other class at the beginning of the class. Okay, I seem to have a real question. So how does Python handle cases where more than one base class has an attribute with the same name? Well, that's actually an excellent question. I'm so glad you asked. I'm not sure. I would think, like, somehow the names of the... I don't know. That's an interesting question. um... Let me get back to you on that. Larry156. I'm not exactly sure. Never tried it. So anyway, again, I'll get back to you guys about it. So abstract classes then. Color only serves as a base class for inheritance in this previous example. One would not create objects of that class that are incomplete for practical purposes. Classes that only serve for inheritance but not for object creation are called abstract. Their purpose is code reuse. So, to some degree, it's an academic distinction. What makes a class abstract is how you use it, rather than anything particular to the class. Although I suppose if you had a class that did not inherit from object, that would make it pretty abstract. But it would also lack things that you would probably want. Yeah, maybe somebody in the chat knows about that question from Larry156. So anyway, if it's not something that's actually intended to ever be instantiated, but just inherited from, we call it an abstract class. So, oh my goodness. So the next example is reasonably lengthy, and I don't think we'll be able to get it in 2 minutes. So I'm going to see if I can answer your question about Python. And also not take any, good lord, phone calls. Yes, I'm aware of the time. So the next live stream is actually sort of completely coincidentally. They finished, like, we did the birthday calendar example at the end of last class. Don't feel bad though. They've had one more class this week than you have so far. Yeah. It'll be a jump forward a bit. I definitely recommend sticking to your own sections with respect to watching the lecture live streams. But, if you want to watch it, then sure. This is an awful lot of, like, talk about, like, a beef between me and Curtis when all I said was, I hope my course is harder than his. Anyway, so there seems to be some, like, if you Google it, if you take a look on Stack Overflow, there seems to be some stuff about multiple inheritance. Anyway, I gotta sign off. Thank you very much for listening to this, the first live stream of our C01 section. I'll see you all tomorrow when we do this again. Same time, same place. Ta-ta!